Charles' law. Charles' law is a temperature volume relationship. Temperature volume relationship. And Jacques Charles. Jacques Charles studied the effect of temperature on volume on fixed mass of a gas. So, he discovered this temperature volume relationship. Okay, so this is called as Charles' law. So, Charles' law states that at constant pressure, volume of the given mass of a gas, increases on increase in temperature or decreases on decrease in temperature. Okay, and it is found that, he also found that for every degree centigrade rise or fall in temperature, for every degree centigrade rise or fall in temperature, for every degree centigrade rise or fall in temperature, volume increases by 1 by 273.15. Okay, volume increases by 1 by 273.5 of its original volume at 0 degrees Celsius. So, volume at 0 degrees Celsius. So, for every degree rise, the volume increases by 1 by 273.15. Okay. So, mathematically, it will be like this. Let at 0 degrees Celsius, volume is V0, and at T degrees Celsius, volume is Vt. Okay. So, Vt, the volume at T degrees Celsius, will be equal to V0 plus T by 273.15 V0. Okay. So, Vt increases 1 by 273.5 of the volume of V plus the V0. Okay. This will be the Vt, or we can write V0 into 1 plus T by 273.15. This will be the volume. Okay. So, Vt equal V0 into 1 plus T by 273.15. Okay. This will be the volume at Vt. Vt, the volume will be equal to V0 into 1 plus T by 273.15. Okay. So, for convenience, they introduced a new scale called as Kelvin temperature scale. Or absolute temperature scale. Absolute temperature scale. Okay. And this new temperature scale is also known as thermodynamic scale for temperature. Okay. Thermodynamic temperature scale also. For scientific works, they are using this too. Okay. So, in this scale, 0 degrees Celsius will be equal to 273.15 Kelvin. This this is the absolute zero temperature, which is approximately we can write 273 Kelvin. Okay, so this temperature is used to explain Charles' law in the modern form. So according to the modern forms, Charles' law states that at constant pressure, volume of the given mass of the gas, is directly proportional to absolute temperature or Kelvin temperature. Okay, this is the absolute temperature or Kelvin temperature, and this Kelvin temperature is denoted by K. Okay, now mathematically we can write V is proportional to T. Okay, mathematically V is proportional to T. That is, volume is directly proportional to absolute temperature. T is in Kelvin. Or we can write V by T will be a constant K2. Okay. Let V1 is the volume at T1 temperature and V2 is the volume at T2 temperature. We can write this like this. That is, V1 by T1 is equal to V2 by T2. Using this relationship, we can solve the problems. Okay, V1 by T1 is equal to V2 by T2. Okay, V1 volume at T1 temperature and V2 at volume at T2 temperature. T1 and T2 are absolute temperatures. Okay. This is the graphical representation of Charles' law, temperature versus volume graph, and here also temperature versus volume. The temperature is taken in Kelvin only. So this is the graph. Okay. So at different pressures, at different constant pressures, we got different curves. Okay. Here at P1 pressure is less than P2, which is less than P3. So at constant pressures, the graphs are plotted. So these curves are also called as isobars. Okay, this is the volume at 0 degrees Celsius or 273 Kelvin. Okay, and volume is V0. If we extrapolate this graph at 0 Kelvin or minus 273 degrees Celsius or minus 273.15, this much degrees Celsius, what happens? The volume reaches 0. Volume equals 0. Okay, so from this we can see that gas will not exist at this temperature. Okay, gas will not exist at 0 Kelvin or minus 273.15 degrees Celsius. And it is seen that before reaching this temperature, all the gases gets liquefied. And this hypothetical temperature at which the volume is 0 is called as absolute zero. Absolute zero. Okay, and this gas obeys Charles' law at very low pressure. And high temperature. Okay. So this will be the graphical representation. Okay. Application of Charles' law. Application in hot air balloon technology. Okay. That is used in meteorological observations. Okay. So, hot air, increase in temperature, what happens? Air expands. Okay. So, hot air expands when increase in temperature. So increase in temperature means air expands. So hot air expands and become less denser. Less dense means they are lighter. Okay, this hot air balloon becomes lighter than atmospheric pressure air. Okay, so it's lighter than atmospheric air. So what happens? But this hot air balloon rises up and floats in air. So it can be used for meteorological observations. Okay, so hot air balloon rises up and floats in air. Okay. A question based on Charles' law. At what temperature will the volume of a gas at 0 degrees Celsius double itself as the pressure remaining constant? Okay. Let volume at 0 degrees Celsius is Vml. Okay, 0 degrees Celsius means the temperature will be equal to 273 plus 0, that is 273 Kelvin. Okay, now according to Charles' law we know V1 by T1 is equal to V2 by T2. Okay, so the second volume V2 will be double. Okay, will the volume at 0 degrees Celsius double itself, so 2V. V2 will be equal to 2V. So V1 by T1 is equal to V2 by T2. We have to find T2. Okay, at what temperature the volume is double. So T2 will be equal to V2 into T1 by V1. And we know V2 is 2V by V into T. T1 we know 273. Okay, T1 is 273 Kelvin. So this will be equal to 546 Kelvin. Okay, this much Kelvin, 546 Kelvin. So we can convert it into degree Celsius. So degree Celsius will be equal to T2 will be equal to 546 minus 273. That is equal to 273 degrees Celsius. So at 273 degrees Celsius, this volume is double. Okay.